let's look at some problems which we can use Fermat's little theorem to solve. Okay, so the first problem is calculate 3 to the 12 mod 11. And what that problem is asking you is find the remainder of 3 to the 12 when divided by 11. The second question says find the remainder when 30 to the power of 2020 is divided by 19. Both these problems can be solved using Fermat's little theorem. Solved using Fermat's little theorem. So let's take a closer look at the theorem. Fermat's theorem. Okay, so the first part of the theorem says that A is congruent when raised to the power of P to A mod P. And there's two conditions. The first is that P is prime, and the second is that A is an integer. Let's take a closer look at that. Let's use an example. Let's do 2 to the 7 should be equal to 2 mod 7. Okay, so we've got 7 is prime. The second condition, that A is an integer, well, 2 is an integer. So let's work this out. Okay, so 2 to the power of 7 on your calculators, you should get 128. It's equal to 2 mod 7. Let's divide by 7 and get the integer part, which is 18 multiplied by 7, and then we need to add 2 on to get to 28. Well, anything multiplied by 7 just goes to 0, so 2 is congruent to 2 mod 7. Now, let's extend our theorem and add another condition. And that condition is that P is prime. And the added condition is that A is not divisible by P. When we have those two conditions, we can apply Fermat's little theorem, which states that A raised to the power of P minus 1 is congruent to 1 mod P. So let's look at some examples where we can use Fermat's little theorem. Let's try 6 to the 10 mod 11. And let's find the value. So we're going to calculate 6 to the 10 mod 11. So let's write the theorem down. And the theorem says that A raised to the power of P minus 1 is congruent to 1 mod 11. So we're working in mod 11, so let's write that power in. We've got 6 to the 10 is equal to 1 mod 11. Well, 10 is 1 less than the mod we're working in, which is 11. So the value of 6 to the power of 10 is 1. Let's look at a more complicated example. Let's calculate 3 to the 12 mod 11. Okay, so we've got the two conditions. P is prime, A is not divisible by P. You can't divide 11 into 3. So let's write Fermat's little theorem. We've got A to the P minus 1 is equal to, is congruent to mod 1, sorry, is congruent to 1 mod P. Okay, so let's do some algebraic manipulation. So we've got 3 to the 12 mod 11. We can write 3 to the 10 plus 2 mod 11. So this is the same as 3 to the 10 multiplied by 3 squared, all in mod 11. We know by Fermat's little theorem that 3 to the 10 is just simply 1. 3 squared is 9, and we're still in mod 11. So our answer is, circle this, 9 mod 11. Let's look at a more complicated problem. Stain yellow. Let's find the remainder when 13 to the power of 39 is divided by 19. So let's write this down. Find the remainder when 13 to the 39 is divided by 19. Okay, so let's write Fermat's little theorem down. Okay, so let's write our power down. We've got 13 to the 39. I hope you realize that we are working in modulus 19. 19 is a prime, and 13 is not a multiple of 19. That is to say that 13 divided by 19 doesn't go. Okay, so we need to get a power of 18. So we can say that 13 is equal to 18 multiplied by 2. 2 18s are 36. And then we need to add on 3 more. Plus 3, and we're still in mod 19. Okay, so let's do some algebraic manipulation. Here, we're going to get 13 to the power of 18, all squared, and then we're going to have 13 to the 3. And we're still in mod 19. Okay, so 13 to the power of 18 is 1 less than our modulus of 19. So by Fermat's little theorem, this goes to 1. And we're left with 13 cubed mod 19. Well, 13 cubed is 2,197. We're still in mod 19. And I am going to do this here. If we divide 2,197 by 19, we get 115 times 19 plus 12, and we're still in mod 19. Well, anything multiplied by 19 in mod 19 is just 0. So we are left with 12 mod 19. Let's look at another problem. And you may want to pause the video and see if you can answer this problem. Okay, so the problem is find the remainder 1/30 power of 20 is divided by 19. Okay, so we've got mod 19 again. Well, the first thing to realise is that 30 does not appear in mod 19. So let's split the screen. So we can rewrite 13 as 11 to the power of 20 mod 19. Okay, so 30 mod 19, if we divide 30 by 19, it goes in once, and we have a remainder of 11. So that is the logic there. Okay, so we've reduced our 30 to 11, and let's divide 20 by 19 and see what we get. Okay, so if we divide 20 by 19, we get 112. And if we multiply that by 18, that gives us the integer part, and then we need to add 4 on to get back to 20. Okay, so just verify that on your calculator. And let's do some algebraic manipulation. So this is 11 to the power of 18, all to the power of 12, multiplied by 11 to the 4, and we're still in mod 19. Okay, so we know by Fermat's little theorem that this is just simply 1. So we've got 1 multiplied by 11 to the 4 mod 19. Okay, so 11 to the 4 on your calculator is 14641, and we're still in mod 19. And let's divide 14,641 by 19, and if you do that, you will find that the integer part is 770 times 19, and then we need to add 11 on to get back to 14,641. We're still in mod 19. Okay, so anything to the multiplied by 19 in mod 19 is 0. So our final answer is 11 in mod 19. So, by Fermat's little theorem, the remainder of 30 to the power of 2020, when divided by 19, is 11.